Hello. Thank you for joining my talk today on how to accelerate microservice debugging with Telepresence. My name is Edidiong Asikpo. It can be quite hard to pronounce my name, even for people that are from Nigeria, so it's not you. In case you can't pronounce Edidiong, there's a shorter version called Didi, so feel free to call me Didi if you ever see me somewhere. I currently work as a senior developer advocate at Ambassador Labs. I'm also a CNCF ambassador and technical content creator. You'd oftentimes find me sharing knowledge on social media, writing technical articles, or building developer communities. And I love to do those things because my tech career was greatly motivated by them, reading people's articles, watching people's videos. So it's oftentimes like a way of giving back to the community. I mean, that's how I like to think of it. I go by Didi codes on all social media platforms, literally all of them except LinkedIn, which is my first and last name, Edidiong Asikpo. All right, so like I said, we're talking about how to accelerate microservices debugging in Kubernetes with Telepresence. So if we think about it, right, Kubernetes and containerization has solved many challenges that businesses face today, including flexibility, scaling, reliability of the release of new versions, and so many other things, right? And some of these benefits are the things that motivated several companies and continue to motivate organizations to adopt cloud-native technologies like Kubernetes, right? Because it enables them to do those things. But one thing nobody really tells you is that even though you get all these many benefits from Kubernetes and other cloud-native technologies, it significantly changes the developer experience we're all used to. It once knew when you started out as a software engineer. I'm assuming you started out when we were mostly working with monolithic applications. But if you didn't, it changes that workflow where things used to move a bit quickly in the inner dev loop. And then now it takes a longer time. And I'm going to explain how that works. I'm sure you probably already know the meaning of developer experience, but I just added this here as a quick reminder, and also because I want to mention something that is very key for the rest of the talk. So developer experience is the workflow a developer uses to develop, test, deploy, and release software. So it's pretty much what happens from the time you start writing the code up until the time when the code is being released to end users, right? And typically, this experience consists of two parts, which is the inner development loop and the outer development loop. So the inner development loop is like, this is typically what it looks like, the code build and test part, right? Where you write the code for a new feature or to fix a bug, for instance, and then you test that code changes to be sure that it works effectively with, like, let's say your other services or any other thing it's dependent on. And if it doesn't, then you go back and refactor your code and then eventually test and all of that. Once you reach a point where you are satisfied with your code changes, right, it means you then push it to version control. So the moment you push it, right, is automatically when the outer dev loop starts. And the outer dev loop is pretty much everything that happens leading up to the release, like, let's say, code merge, canary release, deploying, all of those good stuff before your code changes eventually reach production where your end users can now access them. So adopting cloud-native technologies have changed this developer experience in two ways. The first one is that there are now extra steps in the inner development loop compared to how it used to be before. And secondly, developers are now involved in the outer dev loop more than they used to be, even though half of their time or most of their time is spent in the inner dev loop where they actually write the code. And of course, this has its own benefits, right? But it also comes with some disadvantages. So we're going to focus more on the inner dev loop in this talk because that's where debugging happens. And I'm going to explain or give you scenarios of how things used to be before the adoption of microservices and how they are now, how that impacts the debugging experience that we're now used to, and how to use Telepresence to solve that. So let's just assume this is what traditional inner dev loop looks like. By traditional, I mean when we're working with monolithic applications, right? Let's say that a developer would spend typically like six hours per day writing code, and that traditional inner dev loop would take 5 minutes. So it means they'll spend 3 minutes coding, for instance, 1 minute trying to build and reload your application, the other minute inspecting it to be sure that it works as expected, and 10 to 20 seconds writing a commit message, depending on how fast you type. And you realize that in a situation like this, if you want to calculate it, they'll be able to make at least 70 iterations of their code per day, assuming they spend 6 hours, and the inner dev loop time is 5 minutes. And the only developer tax they will spend here is on the commit, which is quite small because, like I said, it's like 10 to 20 seconds just to write a commit message and push it to a registry. However, with the adoption of cloud-native technologies, this inner dev loop changes from this to this. Of course, coding still remains the same. You're still spending the same amount of time coding, but then you now have to always containerize your application, push it to a registry, and deploy it into a Kubernetes cluster before seeing the impact of your code changes. And it might seem trivial, like, oh, sure, maybe let me just go and drink a cup of coffee, for those of you that like coffee, or let me just quickly complete this Netflix series where I'm trying to, no, not series, episode. Series is quite long. Let me quickly complete this Netflix episode while I'm waiting for for the code to be containerized. But if you think about it, you realize that the amount of time you're spending on these things could have been utilized for what really matters the most, which is writing the code, testing it, and sending it out to production as soon as possible. So if you wanted to calculate this using the same 6 hours per day, you'd see that the iterations has now reduced from 70 to 40. And the developer tax now spent here is no longer on the commit, which was like 10 to 20 seconds, is now on the build push test cycle, where you finish writing the code, you're all excited, you're ready to get this going, but then now you have to wait for it to go through that cycle. And this is oftentimes dependent on several things, right? If your laptop is not as powerful, does not have a lot of space, it might take longer. Or let's say you're in a place that does not have good internet speed. That also contributes to how fast this might go. So in some cases, it even takes longer than 4 minutes. Or maybe the application you're trying to containerize is really, really big. It would take like a long time. So this slow inner dev loop impacts everybody, right? The front-end developers now have to wait for previews of back-end changes on a shared dev environment or rely on mock when coding their application locally. And then back-end developers, on the other hand, have to wait for CI/CD to build and deploy the applications to a target environment to verify that their code is working correctly. And like I said, it's not just the developers, right? The slower it takes to send things out to production, it also impacts the users. So let's say there was this bug that was impacting a lot of people. Let's assume you're working like a fintech company, for instance, and there is a bug that needs to be solved. With fintech companies, issues like that oftentimes makes the company to lose money, right? Or prevent your users from being able to access the application. So the slower it takes to be able to send that bug fix to production, it impacts your users, and then also possibly impacts the company as well, because if your users are not happy, the business is also not going to be good. So a slow inner dev loop does not just impact or affect the developers developing the tools, but it also affects the end users and the company at large. So is there a way out? Is there a way to enjoy the many benefits that Kubernetes provides without having to deal with this slow inner dev loop? And the answer is yes. There are a couple of ways that people have tried to do this, and I'm going to explain the two common ones and then share where Telepresence fits into this. So the first option is running everything locally. So with this option, right, you have, it gives you a fast feedback loop because everything is local. When you make a code change, you can see it instantly. And then it's also very cheap because you don't have to spend money on lots of Kubernetes clusters. We all know how costly that can be. And imagine spending that on every single developer on your team or developers in like different teams in the company. It can be quite pricey. But we're running everything locally. It's like relatively cheap. However, it has a very high maintenance, right? Because you always have to keep updating that API script or the mock data to ensure that everybody is on the same version and is running the correct thing. And then, even though this might work for a certain point in time, there's a point where your application reaches that it can no longer run on your laptop, right? It would start making your laptop really, really hot or start hanging or becoming slow. And this even happens where you're like doing random things like Slack, your emails are open, so many other things are happening on your laptop, and then it starts hanging. So imagine now running a Kubernetes cluster where you have like so many things running on it. It would make your workstation to be very hot. But then another good thing in this side of development I forgot to mention was that you get access to all of the local tools for debugging. You can add breakpoints, you can set up your debugger, you can see logs a lot quicker, like all of those interesting things that you could do when you were working with the monolithic architecture, right? So even though this local development has like fast feedback loop, ability to continue using the local tools you love to debug, low cost, the high maintenance and hot like workstation is not very effective, right? You need to move off of this at some point, or it may not necessarily help you to achieve the things you want to achieve. So the other option then is running everything remotely. And because everything is now in the cluster in the cloud, your computer's workstation is great, right? You're not running anything locally, so it's not impacting anything. And the maintenance in this situation is also really low because you can set up like CI systems that would automatically always confirm that everybody's on the same, like running the same services or is working as expected, right? But then the cost is really high. Unlike running everything locally, you have to pay for these Kubernetes clusters, right? And depending on the number of developers in your company, it can really cost a lot. And then the development loop is really, really slow. Every single time you make a code change, you have to containerize that code change, push it to a registry, deploy it into a cluster before seeing the impact of your code changes. And then you lose out on all of those things you could do locally, adding debuggers, setting breakpoints, even seeing logs might be a bit harder than it was when you were running everything locally. So yes, it does have the great temperature for your laptop, everything is running online, and then the maintenance is low, but then the high cost and the slow development can oftentimes be a problem. So the question now is, you can see that each of these development patterns have pros and cons, right? They have like good sides and bad sides. So can you combine the goods of these two things together and enjoy the benefits of them without necessarily losing out on? So if you decide to go for local, right, it means that yes, you're enjoying, it's cheap, fast feedback loop, but then your laptop is always hanging, the maintenance is high. But if you want to go for remote, you don't have to deal with those things, but then there's also cost and the slow feedback loop. So what if you could combine these two things together and get the best of both worlds? And that's exactly what Telepresence does. So this now creates a development environment called remote call, right? We talked about local, we talked about remote, and then this is the remote call. It kind of merges the remote and local together. So you see here that the benefits here, you have low cost. So even if your application is running in the remote cluster, it's now a shared remote cluster through isolation. You don't need to use as much remote clusters like you used before. And the maintenance is still low because, again, you can still continue using the CI/CD systems that enable you to enable every single developer on your team to be on track and use the right services when testing. And then the temperature is low because more than typically what you need to develop on your computer is just like one service, one Kubernetes service, while every other Kubernetes service and all these other dependencies can stay in the remote Kubernetes cluster or in the local cluster you're using. And then the feedback loop is really fast because you no longer have to wait for the build push test cycle. You're just going to use Telepresence to run an intercept. So you're pretty much moving from build push deploy to test to code intercept test. This may not make sense now, but when I show you the demo, it would make a lot more sense. So this remote call approach basically combines these two things together to give you the best of both worlds. So what is Telepresence? Telepresence is a CNCF tool that simplifies how teams test and debug on Kubernetes. And it does this by allowing you to connect your local machine to a cluster via a two-way proxying mechanism, which allows you to access clusters' resources as if they were running locally and reroute clusters' traffic to your local services. So let me show you a demo. I have a video, 1 second. All right, so from my time with giving talks, I've often realized that most times the demo god is not on your side. I don't know, has anybody ever experienced that? Trying to do a demo and then it doesn't work as expected? Anybody? Okay, cool, awesome. So oftentimes I think it's usually best to have like a video running. I'm happy to do like a live demo for anybody after the talk if you want to see that, because we have a lot more time and we're not restricted by me finishing this talk on time. Anyway, so this video includes the demo of Telepresence, 2 key features in it, which is Telepresence Connect and Telepresence Intercept. Telepresence has a couple of other features, but I'll be focusing on these 2 today because of the limited time that we have. Right, so like I mentioned, how Telepresence works is that it allows you to connect your local machine to a cluster. And then we also have something called Telepresence Intercept, which allows you to reroute all or a subset of the traffic intended for a service in the cluster, to a service running on your local machine. So combining these 2 tools will now enable you to test and debug faster. So you spend less time building, containerizing, and deploying code, and just focus on things that really matter, which is getting your code, seeing the impact of your code changes as soon as possible, and pushing it to production for your end users. So the first thing I'm going to do here is, all right, so the first thing I'm going to do here is run, oh, this is so dark. Can you guys see any of those commands? It's so low. Can you see the screen? Okay, cool. All right, so this is me running the Telepresence Connect command, and what this does is that it connects my local machine to the cluster. You can see that here. I'm trying to highlight it, saying connected to context kind, Telepresence Quickstart. That is the cluster here. So with this now, I can now access clusters resources as if I was another resource in that cluster. So for instance, I just ran kubectl get services to see all of the services inside this cluster. And if I wanted to access, let's say, the very large Java service, for instance, I can do that directly via DNS. So in this case, I don't need to type in the IP address, and that's because Telepresence has merged my local IP routing tables and DNS resolution to the cluster, meaning that I can now access this service directly using the DNS name. So you can see here, very large Java service.default colon 8080. So I can access this very large Java service here, like I'm just inside the cluster without having to do any complex configuration or setup or any of those things. Telepresence Connect enables you to feel like you almost put your laptop inside the cluster. So every single resource inside that cluster would now be accessible by you. You don't need to push your code changes to the remote Kubernetes cluster or local cluster that you're using to test the impact of your code changes. So before we continue, a quick explanation of what this application is. I have the data processing service, which is the service that I'm going to be working on locally, right? This is the only service that we're working on locally. And then I also have the very large Java service, which is too large for me to run on my machine locally. And I'm going to use, Telepresence is going to help me connect to that service. And then I also have the very large data store, which is also too large to run locally. And it's one of the services that was created when this application was built many years ago. So it's very crucial to always test whatever changes you're making with these 2 services, especially the very large data store. So because of with Telepresence Connect now, I've been able to access the very large Java service and the very large data store directly from my local machine without having to do the whole build push test cycle. So with this connection now, I can proceed to run what we call Telepresence Intercept. So like I mentioned, connects your local machine to the cluster, and then you now use Telepresence Intercept to reroute that. So this next command, let me quickly move there, 1 second. Oh, before we start that, some bit of context here. So if you notice the application, you see that the UI color here is green. For instance, the welcome to EduCorp web app, and also the color here for the data processing service is set to green. So what I'm going to do now here is that I'm going to start up the this data processing service that I have running on my machine locally. It's like a Python app. And then what I'm going to do is I'm going to use Telepresence to intercept the traffic that was intended for this service, data processing service in green, which is the one running the remote in the cluster, to the service on my local machine. So to do that, we're going to, so this is me starting up the local application. You can see it on the left. And then the next thing I'm going to do is run the telepresence. Okay, one second. Let me quickly move that backward a bit. So on my right, sorry, on your left, where you can see the Python app, where I just run Python 3 appy, which starts up the application locally. It's running on localhost 3000. And then just to confirm, so you can see how it's going to work, the next thing I'm going to do is run a curl command to see the color of that data processing service running on my local machine. So you can see here that I did curl localhost 3000/color, and it returns blue. It's really small, so I don't know if you can see it, but you can see that it returns blue. So once I run the telepresence intercept command, what that is going to do is it's now going to intercept, more like reroute the traffic that was intended for the data processing service in the remote cluster that is green to the data processing service running locally on my machine that is blue. So let's see that happen. So telepresence intercepts. So this is telepresence list where you see the number of services in the cluster that you can intercept. The data processing service, very large data service, and all of that. So the command here I'm running is telepresence intercept data processing service -- port 3000. And as you can see here, let me quickly move back a bit. All right, so you can see here that it's saying, hey, we've used this deployment, and then this is the intercept's name, the destination, and it's intercepting all the TPC traffic. So if I press play and I go back and reload my application, you'd see that instantly the traffic is now being redirected to the local service, right? And I can instantly see that change. So let's assume that I made a code change. I can immediately see how this code change I've made, which is data processing service, interacts with the very large Java service and the very large data store instantly. Like I don't need to do the build push test cycle. So I'm basically moving from that to just having to run telepresence intercept, and I see that feedback loop a lot faster. So now I've showed you how to use telepresence connect, and I've also showed you how to use telepresence intercept, which routes the traffic. So if you combine these two things, you see that we can use it to debug our application, use it to make testing a lot faster. So I'm going to go to my IDE now, and I'm going to update the color of the data processing service. All right, so I'm going to update the color of the data processing service from blue to orange. And I'm going to save that. So as soon as I save the local server that I started has already said that, hey, something has changed, and then it's restarting the server, right? So if I now go back to my application and reload it again, you see that it has instantly changed to orange. Again, let's take a step back. So if you typically wanted to do this, after you made this code change, I know it's just like a change of color, but think of like a huge debugging thing that you're trying to do, right? Or like an application that has so many other services. This is just 3 services, but most often than not, cloud-native applications don't just have 3 services, they have a lot more. And you can't run all of those things on your laptop. So right now, the only service I'm running on my laptop is the data processing service. That's the only thing I need to change. Every other thing is still in the cluster. I don't need to run it locally, but I can now test to see that this code change I have made is going to work with these other dependencies without having to go through the build push test cycle. So that's pretty much how telepresence works. All right, I'll go back to my slide. All right, so in the demo, I showed you global intercept. So global intercept pretty much reroutes all the traffic. So you could see there that after I ran telepresence intercept, I went back to the to my page to reload, it instantly changed the color. But then there are certain times where, let's say, myself and my colleague are working on the same application, and I don't want, let's say I added a breakpoint while I was trying to do this like testing or debugging, and I don't want whatever I'm doing to impact my colleague because we are using a shared cluster, right? So Telepresence has another version, another like feature, which is called personal intercept, where in this case, only requests with a particular HTTP header will be routed to your machine. So that means that, let's say I here can be using Telepresence to do some debugging with the same cluster, and then you on the other hand is trying to test something else and will not be impacted with what I am doing, right? Does that make sense? Yeah, okay, cool. All right, so that's like the difference. And if you want to run personal intercept, the only change in like the command is from running telepresence intercept to just telepresence intercept, adding a HTTP header, and then you can now use like a mod extension or use the paid feature of telepresence, which would automatically add this header for you. All right, so there are a couple of companies that have used telepresence, and I figured I'll just do like a quick example of like what happened before and after they used Telepresence. So the first company here is called Things. It's called Culture Code, but they're the creator of the Things app. It's like a to-do list app. And pretty much before they used Telepresence, one of the things they used to struggle with was that their development environment was always quite different from their production environment. They had like mock setup to like do their testing, right? And whenever they do testing, they'll think everything is awesome, let's go. And when they push it to production, they'll now realize that, oh, something is missing. There's a bug that was not spotted because the local environment that they had set up for these testing purposes wasn't as identical or like as close to the production environment as they wanted it to be. So this was before they used Telepresence. And then after they used Telepresence, one thing they said was that they now had a development environment that resembles production very well. In their words, they said, we can now develop against the same database running in the exact same configuration. And when we develop something, we can be sure it's 100% compatible with our production environment. There was no longer a surprising missing environment variable, incompatibility between production and mock databases, and they could even catch bugs before shipping to production. So this is like a before and after of this company. Before they used Telepresence, they were always struggling with compatibility between their development environment and production environment. But after they used Telepresence, they were able to solve this problem, right? Meaning that they now had a more stable environment. It made debugging faster for them. And then the other company is VoiceFlow. So before Telepresence, they always had to go through the build push test cycle. This was a company who just recently transitioned from like monolithic to microservices, right? So when they use monolithic, when they made a code change, they would see the impact of their code changes immediately. And like most of us, they heard all the amazing things that microservices and Kubernetes and all those other cloud-native technologies could do for you. So they made that transition. And even though they enjoyed all of those other things that Kubernetes provides, one thing they really struggled with was their inner dev loop became really slow. They spent lots of time doing stuff that usually used to take them like seconds or minutes to do. So they usually used to go through the build push test cycle, and then they also had a slow inner dev loop. But with Telepresence, the need to constantly build and deploy test images was removed, and it increased the speed and fidelity of their inner dev loop. Then finally, we have like a fintech company, and without Telepresence, they didn't have a really good developer experience. But with Telepresence, their developer experience significantly improved. Before, they used to bear all the operational and resource burden of running all their microservices locally when they wanted to make like tests and all that. But with Telepresence, they did not have to do this. All they needed to do was just run the service or services that they wanted to test, and then the rest of them was in the cluster, whether remote or local. So without Telepresence, they couldn't necessarily utilize both the benefits of local and remote development. They started out with local development. It wasn't really great for them because they were a fintech company, and then they transitioned to remote, which also had its challenges, like I shared earlier. And they really wanted to have like a mixture, but they wanted to enjoy the benefits of these two development environment. And then with Telepresence, they were able to get the best of both worlds. They could now utilize their local dev tools, they could add debuggers, breakpoints, all of these interesting things you could do with local development. But then everything was running remotely as well. So they could they didn't have to like deal with like slow laptops or having to maintain lots of like APIs or like mock data. And then finally, they moved from having to do code, build container, push to a registry, deploy and wait, then finally test, to code, Telepresence, intercept, and test. So wrapping up, Kubernetes and containerization, like I mentioned earlier, has solved many challenges that businesses face, from flexibility, scaling, reliability of the release of new features, new versions rather, and so many other amazing things. But it also posed additional challenges for developers by introducing operational complexity into their development workflow. So to solve this problem, we really need a thing or like a tool that bridges the gap between clusters and local dev environments. So you still enjoy the benefits of having to run things in a cluster, right? But then you also still want to use these local dev tools to be able to debug effectively or increase the time you use to like check the impact of your code changes. Because if you think about it, it's not every single time you make a code change that it would work as you expect, right? And we often need to test that, then go back to refactor, and then push it to to version control system when we are ready. So the faster you can do that, the better it is for yourself, for the company, and for the end users. So this is exactly what Telepresence does. It gives you the best of both worlds for you to be able to use. Like I mentioned, it's a CNCF project, meaning that it's open source, so you can definitely contribute to this project at telepresence.io. And I also added a link for you to try it out, but if you want to, the website for it is telepresence.io. All right, thank you very much. Do we have time for questions? If yes, then. Okay. Okay, does anybody have questions? Okay.
Hi. This might be an obvious question, but when you do this telepresent intercept, does it intercept all the traffic or only the traffic from your machine? So, for example, when you intercept traffic from production, would your machine be bombarded with production workloads?
Yeah, so it has two options, right? It can either intercept all of the traffic or it can intercept a subset of the traffic. And what it does is, so let's say you have 3 services in your cluster, for instance, right? Right, and you want to make a code change to one of the services, but this one that you want to make a code change to is dependent on these other 2. So typically you want to be sure that when you push it, it's going to work with those 2 services. So what Telepresence does here is that it removes the need to have to containerize, build, and send that to a Kubernetes cluster before seeing the part of your code change. What it's going to do is going to reroute the traffic that was intended for the service, the original service you're trying to change, right, in the cluster to the service on your machine, right? And then it also gives you access to that cluster. Like it's almost like it carries, let's say your laptop is what is running the local service you are changes. It almost like it carries your laptop and puts it inside the cluster. Right? It could be the one in staging or testing, whatever cluster your company uses for testing purposes. So it almost like it carries your laptop and puts inside that cluster, meaning that you can access every single thing in the cluster, the services, the databases, every single thing in it. And because you can access that, you can now reroute the traffic that was intended to the service in the cluster to the service on your machine, right? Meaning that you can then test to see if this change you've made is going to work with these other dependent services. Don't know if that makes sense. So it mostly reroutes it from the service in the cluster to the service on your machine, not the other way around. Because what you want to do is to test that the change you've made, right, is going to work with these dependent services in the cluster. Does that answer your question? Okay.
Hi, I have one question. Maybe I'm not able to understand the part. So does this cluster, so this Kubernetes cluster need to be hosted by, for example, in the company I'm working for? Is it like hosted somewhere which is, because I'm really not able to understand where this cluster is exactly located. Is it from my company or my own or by the provider?
Anywhere, to be honest, anywhere. It could be your local kind cluster or Minikube, or it could be the one on GKE. So what Telepresence pretty much does is do a proxying, right? It proxies your local machine into the cluster. So wherever it is, as long as you run the Telepresence connect command, and then you typically have to pass the context of the Kubernetes cluster, like maybe in your kubeconfig, for instance. So if you're in that cluster, right, and you run the Telepresence connect command, what it's going to do is proxy your local machine into the cluster. So it doesn't matter where the cluster is, as long as you have admin rights to it, for instance, or you have, your context is passed to, your kubeconfig is what is passed there. So when you run it, because if let's say, I usually use QB, right? So if I use QB-CTX and I'm on Docker desktop and I run Telepresence connect, it's going to connect my local machine to that Docker desktop cluster, right? But if I'm in a different cluster and I run Telepresence connect, it's going to connect to that one. So it depends on which cluster you're currently accessing. Yes, so that's how you do the connections. So it really doesn't matter where the cluster is. Awesome.
Hi, thanks for the presentation, quite insightful.
Azure.
You showed us an example where you had sort of 3 services running, and sort of the naming scheme suggested that the 2 are very large to run on your laptop.
Yes.
So actually I'm interested in what can we do about those. So they're presumably very large to run on your laptop. So how do we debug those?
How do we what?
Debug those. Is there any option with Telepresence to do anything about those?
Yes, so in that case, right, so how Telepresence works is, yes, we know that there are some services that are larger than others, right, and some that are smaller. So the unique thing here is that typically you would have had to run all of those services locally or all of them remotely, right? Or like if you're running all of them locally, it means that your laptop is taking like a lot more space, it's probably slower, it's all of those stuff. But if you're running it remotely, it means that every single time you make that code change, you need to push it there first to see it. So the unique thing with Telepresence is that, fine, even though it's a large service, you only just need to run just that large, whatever, depending on how large it is locally. So think about it, it's better to run one large service than 50 large services, right? So you just need to run that one large service locally, and then you can connect your local environment, which has that one large service, to the cluster, right? And then you'll be able to interact with every other service inside that cluster, which is like the other 49 large services, right? And get the feedback loop instantly, right? Does that make sense? Yes, so if it was locally, it means, oh, you probably have to run those 50 services locally. If it was remotely, you run all those 50 remotely, but then now you always have to do build push tests for every single code change, every single refactoring you need to do to see the impact of the code changes. But with Telepresence, you don't need to do the build push test. You also don't need to run all of the 49 locally. You just need to run the one you are changing. And then with that, you'll now be able to access all of the other services in the cluster. So you're testing against the exact database, the exact services, no mock thing that probably, like maybe there was a mistake in the environment variable, there was a mistake in when you're setting up the mock, maybe someone made a change and did not update it, right, and you're not aware of that. So Telepresence just allows you to access the actual services in the remote cluster. So that means that when you eventually make like your debugging and your testing and it works well there, the chances of it working in production is a lot higher as opposed to using like a mock service or a mock database. Cool, thank you.
The example you put up with the 2 developers. So is it possible to be able to have a front-end developer that's using the shared services and having its request called to a back-end developer or a microservice developer, so that if I'm developing on the front end, I have my local code base running locally and I'm using their service that's running on their machine locally?
Yes. So if I understand your question, you're asking, is it possible for, let's say, a front-end developer to route traffic to their, like do their own testing and then give that developer environment to a back-end developer? Is that your question?
No,
Okay.
it's close.
Okay.
So as a front-end developer, I'm running my local code locally using the back-end shared services. And then my colleague is making updates to the back-end that I need to use.
Yeah.
So can I route my traffic from my local development environment into their local development environment?
That's an interesting question. Yes. So if you do the so like I said, there's global and personal. Yes. So if you do global, it means it affects everybody.
Yes.
So whatever you're doing, he would also see it there.
Yeah.
Yes. So if you then do personal is now saying, because most times not everybody's working on the same thing, right? So he's now saying, do what you want to do, but don't disturb me, like don't impact what I'm doing. Yes.
Right.
So in that case, you would do global intercepts, meaning that it won't just impact just you and your colleague.
Oh, okay.
It impacts everybody in the company.
Yeah.
But there's also, but that's like a paid feature of Telepresence anyway, that it has like preview URLs of your personal intercepts. So as a front-end developer who makes like a code change, you connect to Telepresence, it's going to generate a preview URL of your local change with those other remote services, and you can send it to me on Slack, for instance, and I would instantly see what you're working on, and I can share feedback. So it removes the need to have to push it to even GitHub set to like make me review. I can actually see it instantly, share my feedback, and like let you know, so you can update it before pushing it to like GitHub.
So this is going to prevent or eliminate the need for the backend developer to finish their work before I can start to use so we can work together in almost real
Exactly.
time to say, okay, you've made that API change. Great, let me just test it out over here to see that it works. Okay, no, you miss. I need this other field.
Yes, yes, perfect. Like you
Right.
just, right, it pretty much removes the "it worked on my machine" stuff. Like, when someone says, "Oh, it worked on my machine," Telepresence helps to remove that because you can see the instant changes immediately. Like, it's not a case of, "Oh, it worked here and did not work there." Yes, that's a very good question. Yes, Telepresence can fall into that as well. Okay, all right. Thank you so much, everybody.